Hi and welcome to the Math Jedi channel. Yes, today we are going to be delving into the world of algebra. And where should we start? Let's go and find out what algebraic terms mean. Yes, we're going to go into some vocab and also take a look at some algebraic expressions. Are you ready? Here we go. Algebra, one of the most popular topics in all of math. Yes, the elusive X, trying to find that. And we're going to talk not about how to find it, but we're going to talk about just vocabulary when we are dealing with algebra, because it's important to use the proper words. And who is going to be helping us today? Well, we are going to have a little puppy helping us today. And I've been working on some new animals to be helping us as we delve into our algebra. And our little puppy's going to be pretty happy. He's going to have pointy ears. I don't know, I have a dog that has floppy ears, but my dog does have a cool collar. So we need a little bit of a cool collar there, and doggy collars, you know, there you go, some dots there and that kind of stuff. And, you know, maybe this dog actually stands up a little bit. You never know, has a little body, little chubby dog. And there we go. And small little paws, like that. And of course, he's like, ooh, I got a fluffy tail. There we go. And maybe he'll wave. Ooh, hello. What are you guys talking about? Apparently the dog has only 3 fingers. It's kind of strange. And yeah, all right. So we got a little guy there's going to help us out. And now let's get into some words that we're going to have to know. So the first thing is, so all these words that we should be knowing. The biggest thing is variable, and this is kind of a symbol or a letter that represents a quantity, a thing that represents, we'll say this represents something. Not very mathy. Now the most famous ones, of course, are X. And the most famous symbol, of course, is pi. So those are the variables that we're kind of talking about. We also have terms. So terms, this is one of the more important ones. So terms, these are separated, and when you see an example, it'll make more sense. A term is separated by plus or minus signs. Plus or minus signs. So for this one, I'll actually give you an example of what a term would be. So let me go and just get rid of this. And I'm going to show you an algebraic expression. So when I say expression, this is always interesting. An expression, I'll give you the most easiest kind of thing. It doesn't have an equal sign. It doesn't have an equal sign. What does have an equal sign? Well, that would be an equation. So an equation, it has an equal sign. And what do we do with expressions? We are always usually asked to simplify them. And what are you doing with equations? You're asked to solve them. Okay, so what does this matter about terms? Well, terms are separated by plus or minuses. So let's say we had a typical expression of 5x plus 2y. And I asked you, how many terms are there? Well, things are separated by the plus or minus sign. So this is kind of like the divider. So how many terms? You have this one, and you have this one. So this would have 2 terms. If I went and had something like this, so say I had the 5x plus 2y minus 7, like that. Well, now it has 3 terms. This is also a term like that. Okay, so terms are separated by plus or minus signs. Equations and expressions. So this is an expression. If I did the exact same thing, but I said equals 7, so the equal sign, this is now an equation, and I can go and solve it and do other kind of fun things as well. Other words that we want to know about, of course we have term, so we have term, but we also have like terms. Now these aren't terms that you simply like because they look pretty. No, not at all. A like term, it has two qualities. It has the same variable, and or sometimes actually even variables. It has the same variables, and they're raised to the same exponent, to the same power. Okay, let's give you some examples. Some examples are going to be key for this one. So like terms. So let's see, we had 5x minus 2y plus 3x plus 10y. Okay, so hey, quick question. How many terms do you see? I see 1, 2, 3, 4 terms. There are 4 terms here. But we could simplify this if we can combine. So you're going to hear this a lot. Combine your like terms. You're going to hear this all the time from your math teacher. Okay? Trust me on this one. So combine your like terms. It has to have the same variable. It has to be raised to the same power. So what variables do we have here? We have x's and y's, don't we? Do they have the same exponent? What's the exponent that's right here that's hidden? Yep, that's right. It's a 1. So these are all the same. So 5x and 3x. And one thing I love to do, this is going to help you a little bit, is I like to circle the like terms. And I always include the sign to the left. Always, always, always. And I like to use different colors too. So we also have y's here. So if I said, like terms, and you can combine your like terms. So if I had to go and combine them, let's take a look. What's 5 x's and another 3 x's? What would that be? How many x's would there be? Well, there would be 8 x's. And let's say you had negative 2y and you had another positive 10y. How many y's would you have? You would have 8y. Now, can you combine, let's talk about common kid mistakes, the KKM. Boom, KKM. Can you combine an 8x and an 8y? I mean, they're both 8s. No. You look at the variable, and they have to be like to combine things. So x's and y's cannot combine. It's like apples and oranges. So you just leave it like that. And that would be your kind of simplified version of combining like terms. So a like term has the same variable and the same power. Now I've said power a few times. So what do I mean there? Let's take a look at an example. Let's take a look at 5x squared plus 2x minus 7x squared plus 6x cubed. Now, these are all x's, aren't they? X, x, x. But the power has to be the same as well. The exponent has to be the same. So this would be considered an x squared. This is just an x. This is another x squared, and this is an x cubed. So which ones could you go and combine? Yes, you are right. You can combine those two. And remember, I always like to circle the sign to the left. That always just helps me out. Because now this says 5 minus 7. What's 5 minus 7, everybody? Yay, it's negative 2. X squares. So you can see like the term, the variable just stays the same. And we still have our other positive 2x. And we still have our 6x cubed. But we can't actually combine these because they are not like terms. So hopefully that gives you a good idea about how like terms works. Now, that's all great. We're also going to take a look at replacement. So we're going to start taking a look at what does it look like when we start giving values to variables. So I like to use the word replacement. And I want to have you do well at this. So use brackets. That's my number one advice to young math Padawans. Use brackets. Also remember your order of operations, BEDMAS or PEMDAS, right? Whichever version you like to use. Or those other people like BODMAS. I've heard of that one too. Ugh, craziness. So BEDMAS or PEMDAS. And yeah, I'm going to show you some tricky stuff that usually catches kids. So I'm going to say this. If x is 2 and y is negative 3, what would be the following? If I had to simplify the following, let's say I had 4x plus 5y. Okay, so I'm going to replace things. I'm going to take this value of 2, I'm going to put it where the x is. I'm going to take this value of negative 3, I'm going to put it where the y is. So when I say use brackets, this is what I'm meaning. So let's get rid of this. So this is what it would become. 4, and I love writing brackets. It's fun. And another bracket. Boom. So what am I replacing it with? That 2, like that orange 2, and that negative 3. Now a couple of things. A little remember. What happens, what's hiding between the 4 and the 2? What's happening there? Remember, there's a hidden multiplying sign. Multiply. So that means 4 times 2, which is going to give you 8. What's 5 times negative 3? That's going to give you negative 15. What's 8 minus 15? Well, that's going to be negative 7. Dun, 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 dun. And there you go. So that's simplifying and using replacement. Now, okay, you're like, oh, that's not too bad, is it? I hope not. It does get more tricky sometimes. It does. So what happens when you have the following? Here we go. X is 3 and y is negative, let's say 5. What happens with that? Well, this is what happens. Here we go. If I have an equation that says 2x minus y, this is great. Let's go and put brackets here. And the brackets would become really important. I'm going to go and put 3 there. And that's at negative 5. Now, what do you notice? Do you notice that there's a double negative? That's why those brackets were really, really helpful. So I'd get 6, and this would actually become plus 5, which would give me 11. So be careful with those negatives when you're talking about replacements. There's another thing that sometimes does occur that I do want to highlight, that are always the good things to kind of highlight. Let's say x was, I don't know, negative 3, and y was 2. And let's just say the question was 5x squared plus 2y. So this would be 5 bracket negative 3, and that is being squared like that. Plus 2 times in brackets 2. So order of operations, make sure you're doing your exponents first. So this is negative 3 times negative 3. So you get 5 times positive 9 plus 4. So you'd have 45 plus 4, and you get 49. Just put that in there. Now, just make sure that you're always using kind of the the brackets. I'm going to show you why in a second. So here's another one. Let's say you had, let's just reverse things around a little bit. Say it was 2y, and say I said it was minus x squared. This is always a good one. So again, I'm going to use brackets. And notice how that minus sign is right here, and the x is right in there. I'm going to go and replace some things. So I'm going to make this minus 3 put there, and I'm going to put that 2 here now. So I still get 4. But over here, I get that minus sign is still there, minus, but what's negative 3 squared? We know that's 9. But look what happened. It's 4 minus 9. So that will be minus 5. So that negative is not attached to that x. It's actually subtracting. It's a tough one to kind of wrap your mind around a little bit, but a really important note. So hopefully you've learned a little bit of some terms, and you've seen replacement happening with algebra. Great job. Thanks everybody for tuning in to another edition of Math with the Math Jedi. Hope you had a good time. You have some understanding of some algebraic terms, and now you can go and check out some other videos that delve into how to solve for that famous letter X. Until next time, have a great day.